Dear students, welcome back to this video number 2 on simultaneous faults. In this video, we shall learn two-port network theory and modeling. It is our learning outcome number 2, LO2. In fact, it has already been covered in the course Electrical Circuit Analysis, but here it acts as a prerequisite for analyzing simultaneous faults. That is already we discussed in video 1, Z type of fault, Y type of fault and H type of fault. What is the role of two-port network for analyzing simultaneous fault? We shall understand in due course of time. But before that, let's understand some basics of two-port network as a revision which we already learned in previous electrical circuit analysis course. So let us first understand what is one-port network. So here I have shown a one one port network. One port network one port network is a two-terminal electrical network in which the current enters through one terminal and leave through another terminal. For example, a resistor. Now, if you take a resistor, say, then this is a one-port network because it has only one pair of terminal, and at one terminal the current enters, whereas the other terminal the current comes out. So it has this resistor, even inductor and capacitor are also the examples of one port network because of uh, one has two terminals. So this is a schematic diagram. Here it is shown a two-port network. So V1, V is the voltage at the input terminal and I is the current that enters into the network and that returns back. So it is a one port network. Most of the electrical networks, what we have in electrical technology, they fall into this category, one port network. So here 1 and 1 dash represent a port. Now what is two-port network? A two-port network is a pair of two-terminal electrical network in which the current enters through one terminal and leaves through another of each port. For example, filters, matching networks, transmission lines. So transmission line is a very best example. We can understand a two-port network. So suppose we have a three-phase transmission line, R phase, Y phase, and B phase. So we have a sending end where the power is injected into the transmission line, and at far distance we have a receiving end where power is received. So this terminal at which the power is injected, it is called as input port, and the power that is obtained at far end, it is called as output port. So this transmission line, a single transmission line, it has two pair of terminals, input port and output port. So it is a two port network. Even transformer also, if I take a single phase transformer, then we have a primary winding, and this is just I'm showing the symbol, and there is a secondary winding. So electrical power is given to the primary winding, okay, and the power is transferred to the magnetic media to the secondary coil, and power can be taken from here. So this is the secondary, which you can take it as output port, and where the electrical power is given to primary winding, that can be taken as input port. So it has two pair of terminal, so it can be considered as two port network. Similarly, antenna can is another example of two port network. Amplifiers, normally we have a transistor which can be configured as amplifier. So for example, suppose if I take a common emitter configuration, so now we can see here this base and emitter acts as an input port, whereas a collector and emitter acts as an output port. So it has two pair of terminals, so it can be regarded as two port network. Similarly, communication system, control system, mechanical system, and acoustic systems. There are so many examples where you have two pair of terminals. Power system, in fact, the power system what we have real in real existing, it is a multi-pole network. For example, suppose if I take a power system, it is three bus system. Now this bus is number one, this bus is number two, this bus is number three, and we have a generators or load connected at each of these ports. Now each bus in the system can be regarded as one port. So this is a three port network. But if you take a real power system, for example in Maharashtra state, where there are plenty number of buses. So it is an example of multi-port system. Okay. Now here is the schematic diagram for the two-port network. So this is a input port is a input port where we have a voltage V1 and a current I1. There is another pair of terminal output port where we have a voltage V2 and current I2. So so this is a two-port network. Okay. Now let us come to two-port network parameters. Now here I have shown the schematic diagram of two-port network. So input port here and the output port here with the voltages and currents V1 I1 as the input parameters and V2 I2 are the output parameter, electrical parameters. Now in this block there may be lot of elements, maybe passive or active elements, and there is a current in this block somewhere. But suppose my interest is only in these four parameters, V1, I1, V2, I2, I'm only interested in these four parameters. But what current is there in this block at any juncture, or what is the voltage at any point in the circuit? I'm not interested, only I'm interested in these four parameters. Then we can have some equations, what we called it as two-port models. V1, V2. Now, if we consider them as dependent variables, and I1, I2, if they are regarded as independent variables, so if you write V1, V2 as a function of I1 and I2, then hello, नंतर करता ah. Now here I have written one equation. Out of these four parameters, V1, V2, they are taken as independent variables. Sorry, dependent variables. And I1, I2, they are taken as independent variables. And we have an equation relating these to four parameters. Then the coefficients of this equation, they are called as Z parameters. They are called as Z parameters. There is maybe another equation. Suppose I1, I2, if they are taken as dependent variables and are written as function of V1, V2, they are independent variables. Then the coefficient of the equation, what we get, they are called as Y parameters. They are called as Y parameters. Now suppose V1, uh, V2, I2, if V1, I1, if they are written as a function of V2, I2, then we get the coefficients relating this equation. They are called as transmission parameters. If you take in the reverse fashion, V2, I2, if they are written as a function of V1, I1, then it is called as inverse transmission parameters. Then we have H parameters wherein V1, V1, I2, they are written as a function of I1 and V2. And if you write it in the reverse ways, I1, V2, if they are written, sorry, I1, V2, if they are written as a function of V1, I2, then we get inverse hybrid parameters. So they called as G parameters. So here the concept is very simple, which is very, very important. Suppose we have an electrical system and we are only interested in the terminal electrical parameters. For example, here I have written V1, I1, V2, I2. Out of these four variables, two can be taken as dependent variables, two can be taken as independent variables. Then we will have different six possible pair of equations. And the coefficients of the equations, they are called as two-port network parameters. They are called as two-port network parameters. Now here we have, let us start with these Z parameters. They are also called as open circuit parameters. They are also called as open circuit parameters. Now, as already told, suppose this is our the schematic of two-port network. We have voltage V1, I1, V2 voltage, and I2 voltage. Now, as I told earlier that V1, V2, now we are selecting as dependent variable. I have written here as dV in short. It is written as a function of I1 and I2. So this is what first equation we get. V1 is equal to Z11 I1 plus Z12 I2. So we can see here V1 is written as a function of I1 and I2. So we get one equation. Similarly, if you write another equation for V2, V2 is equal to Z21 I1 plus Z22 I2. V2 is written as a function of I1 and I2. Then the coefficients, here what we have, Z11, Z12, Z21, Z22, they are called as Z parameters. Now, how we can find, this is practical approach, what is given here, but we can have an analytical approach also. Here we can have a numerical approach or practical approach. So how I can find Z11 parameter? So if you want to find Z11 parameter, uh, you can now look at this equation. In this equation, if you put I2 0, if you put I2 0, this I2, how we can make I2 0? Keep this output port open. If you keep this output port open, then I2 will be 0. And under that condition, what your equation will modified, it will be V1 equal to Z11 I1, and we will have second equation Z21 I1. I2 is made 0 by open circuiting the output ports. So that's why it is called as open circuit parameters. Now how we can find Z11? Z11 it is equal to I1, sorry, V1 divided by I1. Now this is Z11 is called as input impedance of the network, and the unit of this parameter is ohm. Similarly, Z21, this can be find out. So Z21 can be find out by equation V2 by I1. So we will have an output voltage. You can measure it by voltmeter, and you can measure the current at this point I1. If you divide V2 by I1, then we will get Z21 parameter. This is called as reverse uh, reverse impedance of the network. Reverse impedance of the network. Similarly, how we can find Z21 parameter and Z22 parameter? Now in that case, we have to keep I1 0, I1 0. So keep the input port open and apply a voltage at this output port from any of the source. For example, you can apply a reference voltage as 1 volt, and you find out what is this I2 current here by connecting an ammeter. Find V1 voltage here at this point by voltmeter. Then you can find Z12 by this ratio. V2 we have set it to 1 volt divided by I1. I1 you are measuring by connecting ammeter, then we will get set to 1 parameter. Z22 parameter can be also find out. V2 we have set it to 1 volt and we have connected an ammeter to measure I2. So V2 by I2 will give you Z22 parameter. So these equations, whatever they are given, this equation by using these uh, can be used practical way of finding the Z parameters of the given network. The Z parameter they are also called as impedance parameters. Now one point I want to highlight here is very important. In the power system we have Z bus. So Z bus. Already we have learned how to form Z bus by building algorithm, and we have, suppose if I have a network, say I have uh, suppose I have a 3 bus system. One now I will have a Z bus of 3 by 3, Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33. What is the difference between the Z bus and these parameters? Now, if you write this equation in a matrix form, we will have the equation something like this. Z11, Z12, Z21, Z22, I1 and I2. What is the difference between these matrix and this Z bus? They are not difference, they are same matrix. Only the difference is that here we have 3 pair of terminals. That's why we have here it is 2 by 2 matrix, and here we have only 2 pair of, we have 2 pair circuit, and so that's why we have this 2 by 2 matrix. Suppose if a power system is only having 2 ports, only 2 buses, then whatever Z bus we get, it will be same as your Z parameters. This is very, very important point to be noted. Okay. Oh, let us come to Y parameters. Now, already I told here, out of 4 variables, V1, I1, V2, I2, we have I1 and I2, they are selected as dependent variable and the equations are written as a function of V1 and V2. So we get 2 equations here. I have written I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Okay, then how we can find this, how we can find Y11 parameter? To find Y11 parameter, we can set this V to 0. If you set this V to 0, then our equations will get modified to this form Y11 V1, and another equation is Y2 Y21 V1. Then we can get from this equation Y11 is equal to I1 by V1. So how to find this Y11 parameter practically? What we can do, you can connect 1 ampere, so we connect one independent current source at the input terminal. Say I have taken it as a reference 1 amps. Now the current will start flowing in the network, and we have to short this terminal because we want to set V2 equal to 0. Now when it is shorted, V2 becomes 0. Now you connect a voltmeter at this point and find V1. Now I1 we have set it as 1 ampere, and V1 we have find it by the voltmeter. Then I1 by V1 will give you Y11 parameter. Similarly, Y12, Y12, sorry, Y2, uh, okay, Y21, yeah, Y21, I2 divided by V1. So you connect one ammeter at this point, find I2, then I2 divided by V1 will give you this parameter Y21. Similarly, Y12 and Y22 can be find out by setting V1 0. That is, short the input pair and apply a current source at the output pair and correspondingly find the current and voltages. These parameters, they are also called as admittance parameters or short circuit parameters. They are also called as short circuit parameters. Why they are called as short circuit parameters? Because we are shorting either the input port or output port for finding the parameters. Okay. Now let us come to transmission parameters. These are very important to us because in one of the subject, I hope transmission and distribution, we are dealing with this ABCD parameters, or they are called as transmission parameters. Okay, now here one important point that okay, as again we have four parameters V1 I1, V2 I2. Now what we are doing, V1 I1, it is written as a function of V2 I2. So we get these two equations, V1 as a function of V2 I2, I1 as a function of V2 I2. Okay, now why a minus is there? Because in actual system, in actual transmission line, the current flow in this direction toward the receiving end, but we are, for modeling sake, we are taking it in the reverse direction, so we are keeping it as a minus here. Okay, now how we can find these parameters A, B, C, D? So to find A and C parameter, what you can do, you open circuit the output port. So you have to set I2 0. So how to set I2 0? Open circuit the output port, and you can connect one voltage source at the input port, say as a reference 1 volt, and you can find the output voltage V2. Now we have set V1 as 1 volt, and now you connect a voltmeter at this point to measure V2. Then V1 by V2 will give you A parameter. Now let us come to C. So I1, now you can connect one ammeter at this point to get I1. So I1 divided by V2, V2 we are measured by voltmeter, so V1 by I2 will give you C parameter. Similarly, B and D parameter, they can be find out by short circuiting the output port. So this is called as ABCD parameter. ABCD, they are called ABCD parameters, or also they are called as transmission parameters. Now, what is the inverse transmission parameters? So I will explain those things here only. I have not made any separate slide for that. If V2, I2, they are written as a function of V1, I1, then we get the parameters, what we called it as inverse transmission parameters. Let us come to the last parameter, the word H parameter, called as hybrid parameters. Now here V1, I2 are written as a function of I1 and V2. So we have these two equations, V1 and I2, V1 as a function of I1 and V2. Now how we can find this H11 and H21? H11 can be find out by setting V2 0, short output port, and apply voltage of 1 volt at the or current at the input port as 1 ampere, and find the voltage at the input terminal and current at the output port. So in this way you can find out H11, H12, H21, H22 parameters. They are called as hybrid parameters. Inverse H parameters can be found out by I1 V2 as a function of V1 I2. Out of these 6 parameters, we are only interested in Z parameters, Y parameters, and H parameters. Okay, so in this video, up to this only, we will continue in the next video. Thank you very much.